Okay, this is a rough guide to buying your first astronomical telescope. So I'm going to be looking at what the different types of telescope are, how they differ, equatorial versus Altaz mounting for telescopes, and I'll be looking at the pros and cons of the different types of telescope that you might be thinking of buying. Then there's a rough guide to prices, and I've arranged for you to get handouts if you don't want to write down anything on the screen. There'll be handouts available if you want to make a note of some of these prices. And I'll finish with a few hints and tips and random thoughts about things that you ought to consider before handing over any cash. So let's just get one thing out of the way. This is not supposed to be a talk that answers the question, what's the best telescope to buy my X-year-old son, daughter, grandson, granddaughter? That's a rather different question. There were lots of cheap telescopes around. Maybe you like the idea of a telescope that looks like that. But there are telescopes that are designed for kids, like this Penguin telescope, for instance. But that's not really what I'm covering here. But I'd gladly take that in the Q&A if you wish, if it's the sort of question you tend to get asked. There is lots of help out there. If you're thinking of buying a telescope, there are some very good guides out on the web. Beg your pardon?
So could you go back a few sentences? We lost your sound there. You sound a bit like a Dalek.
From here?
No, take it down.
Start at the Celestron.
Start at the Celestron handbook.
Here.
And again, yeah.
That's it there.
Okay, there's lots of help out there. There are some well-written beginner's guides available on the web, but do remember that if you have a guide like this, which as you can see in the top right-hand corner is sponsored by a particular telescope manufacturer, then bear in mind that that's the only type of telescope that you're going to find inside such a guide. So that being said, this particular guide is actually quite a good one. It gives you a lot of information about the different types of telescope. It tells you, for instance, what to think about, what to consider if you're thinking about buying a refractor or buying a reflector. It tells you about the different types and the different mounts, and it also tells you a little bit about accessories as well, including eyepieces and thinking about binoculars versus telescopes. So that's all very useful. You might alternatively go to something more like a guide which is really a catalogue of telescopes sold by a particular manufacturer. And again, that can give you a large amount of information, but if anything, it can be a little bit too much. This, for instance, gives you a lot of information about each telescope you might be considering buying, but here, 6 random pages, there's an awful lot of information, and it goes on, and there are more and more telescopes, and more telescopes, and lots more telescopes, and lots more telescopes, and lots more telescopes, and then you get onto mounts, and then you get into accessories, and then you get into eyepieces and filters, and that's only a tiny fraction of that catalogue, which is nearly 100 pages long. So even though it's got a huge amount of information, which is fantastic, it also has so much information that it can be rather confusing. So let's just have a look at some of the telescope types. So some telescopes use lenses, use glass to focus the light, and some telescopes use mirrors. And although we talk about lenses and mirrors, the technical term for these types of optics are called dioptric and catoptric. The only reason I'm using those words is because in the middle there, in the overlap, you have some telescopes which use glass and mirrors to produce an image, and that's why these particular telescopes are called catadioptric. A bit of a mouthful, but it's a concatenation of dioptric, which means lenses, and catoptric, which means mirrors. So we're not going to use those particular labels. We're just going to refer to refractors if we're dealing with lenses, and reflectors if we're dealing with mirrors. But when it comes to the telescopes in the middle that use lenses and mirrors, there's not really a good name for those other than catadioptric, and that's too much of a mouthful, so we're just going to refer to those as cats. Okay? Refractors, reflectors, and in the middle there, cats. So let's just think about refractors. a lens at the front and an eyepiece at the back. This particular one has a little 45-degree kick so that the eyepiece is at 90 degrees to the telescope. That's purely for comfort. It's got nothing to do with the optics per se. So the objective at the front of the telescope will focus distant starlight to a focus, which is then viewed with an eyepiece. And I'm not going to be talking about different types of eyepiece in this little workshop here. If we only have one piece of glass focusing the light, then it's not going to bring all colours to the same focus, and so you'll suffer from colour fringing, where you can't get all the light of different colours in focus at the same time. And manufacturers of refractors try and get round that. Instead of having just one lens at the front, they'll have multiple lenses or multiple lens elements in the objective lens. And essentially, the more elements that you have, the more that you can get colour fringing under control. But the more it costs. So the better the quality of the image, the more glass that's in the objective lens, usually the more expensive the refractor. But alternatively, rather than use glass to make a focus and then have problems with colour fringing, if you use mirrors, you don't have that problem. So in a Newtonian design, a parabolically shaped curved mirror focuses distant light to a point, but you don't want to put your head there because you block the incoming light. So in a Newtonian telescope, a flat mirror will kick the light out sideways, and that gives us the classic Newtonian with an eyepiece on the side of the tube, usually close to the top edge. Alternatively, you can have a mirror bring the light to a focus, and instead of a Newtonian kicking it to the side, in a different design called Cassegrain, a curved mirror sends it back down the length of the telescope through a hole in the main mirror. That's a Cassegrain design as used by, for instance, the Hubble Space Telescope. And another version of the Cassegrain is called the Schmidt-Cassegrain, which looks very similar. It has a spherical mirror, which is a little bit cheaper to make than a parabolic mirror, and that means that there are some aberrations, some distortion of the light, which is corrected by a piece of glass that's at the front of the telescope called a corrector plate. And so when you look at this design Schmidt-Cassegrain, you notice that the front of the telescope is what appears to be a flat piece of glass. But you can see one of the advantages of this type of telescope. You see, because the light has been folded inside the tube, you get quite a large focal length, so you get a lot of detail in, for instance, small objects like planets, but it's in a relatively compact tube. And in a similar way, a slightly different version, instead of bouncing the light off a mirror which is held in place on a glass plate, a Maksutov design has a curved glass plate at the front, and the secondary mirror that reflects the light back down through the centre of the main mirror, that's actually painted on the inside of this corrective glass plate. And because that glass plate is curved, you notice that a Maksutov has this particular characteristic that the front element is dish-shaped. So you can recognise a Schmidt-Cassegrain telescope because it has a flat piece of glass at the front, and a Maksutov has a curved piece of glass at the front. But again, you get this folded light, which gives you quite a long focal length in a relatively compact design. But we have to think about how all these telescopes are going to be mounted, because they can't just float in free space. And the cheapest telescope mount is an altazimuth, which means that the mount can move in altitude, up and down, and it can move in azimuth from left to right. And some altazimuth mounts are motorized and can be even controlled by your phone, by your smartphone. Generally speaking, a manually operated altazimuth is one of the cheapest types of design. If they're motorized, it's going to cost you more. If it's computerized, so that the computer decides where to point the telescope, then it's even more expensive. So basically, the more the mount can do, the more expensive it is, the more you end up paying. But a different type of telescope mount has the axes at rather jaunty angles compared to just left, right and up and down, which seems nice and simple. Why would you want to go to a telescope mount with axes at such jaunty angles as that? Well, if we think about the way the Earth spins with its axis pointing to the North Celestial Pole, rotating once a day, of course. Then if we think about a telescope in England at a latitude of 50-something degrees, then of course the axis of the Earth is now at an angle relative to the horizon. And if we align our equatorial mount parallel with the Earth's axis, that means we only have to drive it on one axis in order to follow the stars. So it actually makes it easier compared to moving on both axes, left, right and up, down, fore and altazimuth. I have to say something about astrophotography, even though that's not the main focus of this particular workshop. Any telescope can have a small eyepiece camera. In other words, you can replace the eyepiece with a small eyepiece camera, and that will work on essentially any telescope. And if you have a telescope with a relatively long focal length, that gives you a reasonable sized image of the moon or the brighter planets, and that enables you to do some astrophotography. But if you wanted to catch some of the deep sky objects like nebulae and some of the faint galaxies, then you would need rather longer exposures, and that would require the telescope to be mounted on a motor-driven equatorial mount to make sure it can follow the stars or the object over a relatively long period of time. And anyone very serious about astrophotography will probably end up buying themselves either a dedicated astro camera, or perhaps they'll use the digital SLR camera that they already have that can be used on telescopes as well. So the pros and cons of why you might want to choose one camera over another, that's a whole different ball game, and so we'll leave that for a future workshop. And remember that if you are interested in astrophotography, that does not mean that you need to go out and buy a telescope. Remember, you can do astrophotography with a camera on, for instance, a star tracker. These 5 images here have all been taken with a camera on a star tracker, either a wide-angle lens or perhaps a telephoto lens, but you can do an awful lot without needing to go to a telescope. But if you do want to buy yourself a telescope and get into astrophotography, well, bear in mind that that can be extremely rewarding, but to get the most out of that, a telescope on an equatorial mount doing astrophotography, you will need to invest quite a bit of time, quite a bit of effort, and I would reckon quite a bit of cash as well. So let's have a look at some pros and cons. We'll look at a refractor in the middle. Top right is a Newtonian, bottom right is a Dobsonian, which is a type of Newtonian on a simple mount. Top left is a Maksutov and bottom left is a Schmidt-Cassegrain. So we've looked at each of those already. So pros and cons. I've already mentioned that if you're dealing with a refractor with a lens focusing the light, then they can suffer from colour fringing, not bringing all the colours of light to the same focus. This is called chromatic aberration. And to some extent, the manufacturers of telescopes will try and bring that under control by having different lens elements in that front objective. But the better it gets the colour correction, the more it's going to cost you. Alternatively, you go for a telescope which has mirrors rather than lenses, producing the main image, and that gets around the problem. So Newtonian telescopes and Dobsonian telescopes. And just for the point of definition, a Dobsonian telescope is simply a Newtonian telescope on the simplest Altaz mount that would keep the cost reasonably low. The two on the left, the two cats, have relatively long focal lengths in relatively compact tubes because the light has been folded by going down the tube, hitting the mirror, coming back up, hitting a secondary mirror and then going back down again. So you get relatively long focal lengths, which means you get reasonably high magnifications for looking at small objects like, for instance, the planets. So both of those are good for looking at detail on the moon or for looking at planetary detail. Large apertures, generally speaking, are better for the fainter objects such as deep sky objects, nebulae or galaxies. And the larger apertures tend to be in the Newtonians, the Dobsonians and the Schmidt-Cassegrain types of telescopes. The largest aperture for a given price, and I'll come to prices in just a moment, the largest aperture for a given price would be a Newtonian telescope on the simplest Altaz mount, which is what's called the Dobsonian type of telescope. Those three on the left, the two cats and the refractor, all have sealed optics, which means the air inside the telescope doesn't mix with the air outside the telescope. And that means that, generally speaking, they are lower maintenance and easier to keep all the optics in good working order. The Newtonian and Dobsonian, by contrast, are open to the elements, as it were. The Maksutov is the smallest cat. The refractors can be quite small, quite compact, and Dobsonians aren't necessarily small. Some of them are quite large, but all of those three are either small and lightweight and easily portable, or if they are large, as in the case of some refractors and some Dobsonians, they are relatively easy to transport compared to Newtonians and Schmidt-Cassegrains. So there we've seen a number of the pros and cons. But of course the elephant in the room is, how much is this going to cost me? So by looking through a few magazines and various web pages, I try to come up with a guide as to how much you can expect to pay for a given type of telescope. So for instance, for £300 you might be able to buy a refractor with a 4-inch diameter lens, or a Dobsonian telescope with a 6-inch diameter mirror. And for those of you who struggle to convert inches to millimetres, depending on your age, there's a little table in the bottom left of the handout that will be made available to you. It's just easier on this to show it as inches rather than to show it in metric millimetres. So you can see that a given aperture is going to cost very different amounts depending on whether you're talking about a given size of refractor or a Newtonian or a Maksutov. Each of them has different pros and cons and different prices. In terms of what do various guides tell you is a good sort of starting telescope, well, most will agree that you would have to start at about £100, and if you can't afford £100, then maybe binoculars might be a better bet than investing in a telescope. But if you've got more than £100 to play with, then some guides will say, well, think about something like a 5-inch Newtonian, which would start at about £200 or so. Other guides might say, you want to go for the largest one you can afford, so you might want to think about a 6-inch or 8-inch aperture Dobsonian. I would argue that pretty much anything in the blue box there is relatively good value for money for what it is. Taking the pros and cons that I've said in the previous few slides and realising that, generally speaking, the more you spend, the more you get, any telescope bought within that blue box will have something going for it and will hopefully give you plenty of enjoyment in stargazing. Sky at Night magazine actually said, why don't you think about an 8-inch Newtonian? But given that those are closer to £700, I would argue that perhaps that isn't really what most of us would describe as a beginner's telescope. So that gives you an idea of, roughly speaking, the minimum you might expect to pay for a given size of a given telescope. And that might help your thinking if you're thinking along the lines, or you're looking at adverts and you say to yourself, well, somebody seems to be selling a 6-inch Newtonian for, let's say, £500, then you can see from this chart that that's roughly the right sort of ballpark. But if somebody is trying to sell you a 5-inch Dobsonian and is charging you £600, then something is very wrong. These are the minimum prices that you can expect to pay. At the bottom here, underneath the telescopes, I've put a couple of lines of astrophotography, reminding you that if you want to get into astrophotography, but you haven't quite got the cash yet to invest in a telescope, then you can think about using a camera on a star tracker. And a do-it-yourself home-built star tracker will cost you perhaps a few tens of pounds. If you wanted to buy a commercial star tracker that's clockwork, that might be £100, and a motorised star tracker would be between £200 and £300. But if you wanted to get into astrophotography by buying a telescope and then doing astrophotography through the telescope, then you will need a good quality, sturdy and relatively precisely driven equatorial mount. And so you'll need to think about something on the blue line at the bottom there. So a motorized mount that's suitable to put on a medium-sized telescope to do astrophotography will be in the ballpark of £300. And if you want a similar mount, an equatorial mount, but one that's computerized to point at the sky without you thinking about where you're pointing, then that would be something closer to perhaps £500. So again, this comes back to what I said earlier, astrophotography isn't necessarily very cheap. So let's have a think about a few hints and tips, a few thoughts. I would argue that you can't go too far wrong if you stick to a well-known manufacturer, such as one of the big five. And here they are listed not in order of quality, not in order of value for money. They're just listed in alphabetical order so as to show no particular preference. BASoc, Celestron, Meade, Orion and Skywatcher account for probably 90% of the sort of telescopes that people buy, especially their first telescope. If you're thinking about a telescope, then you have choices of aperture, the size of the lens or mirror letting in the light, and you have the choice of focal length, essentially the length of the telescope if it's a refractor, or it's a slightly more complicated calculation if it's something like a Schmidt-Cassegrain or a Maksutov. But essentially, aperture is important because that decides how much light is caught by the telescope. The focal length determines the magnification of a given eyepiece. And whilst we're thinking about eyepieces, bear in mind that you often don't get a choice in the sense that when you buy a telescope, you might get one or maybe two eyepieces that will be provided to give you an appropriate magnification to start with. I would suggest you might want to buy a telescope, and after using it for a little while, then you can decide whether or not you would like a larger range of eyepieces or eyepieces with lower or perhaps higher magnification. Bear in mind that high magnification is probably less important than you think. But generally, telescopes with long focal lengths will give you higher magnifications than telescopes with shorter focal lengths. One thing to bear in mind is not only the parameters of the telescope in terms of the quality of the optics and the size of the objective, etc. It's the ergonomics. Where are you going to be using this telescope? Will you be carrying it indoors and out into the garden on a nightly basis? Is it going to be sitting on a tripod? Does it have to sit on a tabletop? In which case, have you got a table that's steady enough to put in your garden and actually use the telescope? Will you be actually carrying it to a dark sky site? Does it have to be portable? Does it have to be transportable? The ergonomics is almost as important as the optics, because if it's a fantastic telescope but it's too heavy for you to lift, then you're probably not going to use it much. And just a final comment about astrophotography, what I harked to earlier, in terms of the quality of the mount you need, that's much more demanding if you're intending to do astrophotography. If all you want to do is to put the telescope onto a mount and make sure that you can follow, for instance, Saturn, such that Saturn stays in the middle of your eyepiece field of view for a nice long period of time, then the tracking accuracy of that mount isn't particularly important. But if you want to do long exposure photography of faint objects, then the precision with which that mount can track the sky is absolutely important. So different criteria depending on whether you're more interested in visual astronomy or astrophotography. Think about whether or not you want to get to know your way around the sky. If you have a manually operated telescope, they really do encourage you to learn the sky and know where the objects are. If you have a computerized telescope that points at objects, then maybe you'll never figure out where the objects are in the sky. Maybe that doesn't worry you. Maybe you want a computer to just point at objects regardless of where they are. Remember, a computer will cost more than a manually operated telescope. And a computer, in a sense, puts you in the back seat because the computer does all the work of pointing the telescope. I would argue that the best way of getting a good feel for the different types of telescope is to try out a few on an observing evening. Perhaps not this evening, perhaps in the middle of a pandemic, that's not the best time to go from one telescope to another, borrowing each other's eyepieces, etc. But it is a good idea if you can have a view through different telescopes to give you an idea of how different telescopes perform. And if you are thinking of buying one second hand, it's a good idea to take advice from members of the society on what you think looks like an internet bargain. It might be a bargain, but it might be a turkey. So take advice if you find something on a social media site that looks like it could be interesting. Try to avoid adding gadgets. This is just a personal comment. Some people seem to buy a telescope and then insist on adding as many different gadgets to it as you can possibly find. Now, by all means do that if you so wish, but some people seem to think that it's a good idea to keep adding gadgets until you run out of cables. I would argue that that's not really what stargazing is all about, and you don't have to. Just because you see other people with 1,000 gadgets on their telescope doesn't mean you have to. A point of caveat emptor, beware. When you look at images of telescopes, especially those on web pages, and also to some extent inside catalogues that you can pick up, sometimes it can be very misleading if pictures are displayed side by side, especially if they are not shown to scale. So those two telescopes, for instance, there are shown to scale. And compared to what we saw a moment ago, that at first glance can make them look very similar, but once you see them to scale, you realise they are very different animals. And you have to decide what is a comfortable viewing height for you. The one on the right is clearly freestanding and for most people puts the eyepiece at a relatively comfortable height. But clearly the smaller of those two Dobsonian telescopes you would not want to use on the ground, you would want it elevated. And so you have to think, am I going to be using this sitting down? Am I going to use it standing up? What do I need to support the telescope? And bear in mind that although most people would say larger apertures are better because they collect more light, well, yes, that's true, but large also means heavy. So the telescope on the left is 2 kilograms, the telescope on the right is 24 kilograms in total. And although that might be a fantastic telescope, if it's too heavy for you to lift or put into the back of the car, then you're probably not going to end up using it much. Remember to read the specification. Make sure you know what you are getting before it is delivered to avoid any nasty surprises. So for instance, that looks like a fantastic telescope, but perhaps unless you read the small print, you don't realise quite what size it is. And yes, that is the size of the Meade RCX. It is. Beg your pardon?
We lost a bit of sound there, but I think it's okay. You can ask questions later.
Yeah, okay. So make sure you know what you're getting, because although it might look very nice in the catalogue... Sorry?
Okay.
Oh, I thought somebody said something.
No.
Okay. Because although it looks very nice in the catalogue, when it actually arrives, you may realise that it's rather larger than you thought, and that is the relative size of the Meade RCX. It really is that big. And if you look on the left-hand side there, yes, it is 300 kilograms. Meade have taken that into account. So although it is a very weighty telescope, Meade very conveniently have made sure that's not a problem because they have ensured that it is completely and totally offset by the fact that your bank balance is going to be an awful lot lighter if you decide to go with a telescope like that. So, final thoughts. Your options are many and varied, and that's good, and also it's bad, and also it's potentially very confusing. Having the choice of 1,000 different telescopes perhaps doesn't help you actually decide which one you want. Try not to suffer from analysis paralysis. Don't spend 5 years comparing the pros and cons of 2 different telescopes to decide which one you actually want. Look at what you can afford. Use the price guide if you wish. Take advice, make a decision, and then enjoy your stargazing. Remember to make full use of the resources of your astronomical society, by which I mean the members. And finally, the best telescope for you, I think everybody would agree, the best telescope for you is the one that you use. So I hope that rough guide helps you on deciding about your first astronomical telescope. Thank you all for listening.